dear students, in our previous sessions, we learned about some simple circuits. We have noticed how the current through the conductor depends upon the resistance and the potential difference across it. In various gadgets like radio, television, we often use resistors or resistances in combination. So today we are going to learn how the combination of resistances takes place, or how the resistances can be connected in combination. So there are two ways of combining these these resistances. Number one is series, and another one is parallel. If we want to increase the total resistance, then the individual resistance are connected in series. And if we want to decrease the resistance, then the individual resistances are connected in parallel. We will study these two cases in detail one by one. When two or more resistances are connected end to end consecutively, then they are connected in series like this, and so on. In this figure, three resistances R1, R2 and R3 are connected in series. Now, on the other hand, when see, like this, when two or more resistances are connected between the same 2 points, they are said to be connected in parallel. For example, in this figure, resistances R1 and R2 are connected in parallel arrangement between the 2 points A and B. We have shown in these cases, we have shown either 2 or 3 resistances. We can, however, connect any number of resistors or resistances in these two arrangement. I mean in series and in parallel arrangement. Now let us study in detail the resistances in series. Now when there is, for this I will have to first of all draw the circuit diagram. I'll connect two resistances in series. Resistance R1 and R2. Okay, I'll connect these two resistances with a wire and a battery. Like this. Now this figure or this circuit diagram shows the two resistances R1 and R2 connected in series. A battery of V volt has been applied to the ends of the series combination. Now, remember that when a number of resistances connected in series are joined to the terminals of the battery, then each resistance has a different potential difference across its end. And when but the total potential difference across the ends of all the resistances in series is equal to the voltage of the battery. So we can write like this: V is equal to V1 plus V2. This can be our equation 1. Okay. And the second important point which you need to remember is that when a number of resistances are connected in series, the same current flows through each resistance. Same current. So I'll write I. No change. Same current. Now we will apply Ohm's law. According to Ohm's law, V upon I is equal to R. Or we can write this like this: V is equal to I into R. This is equation number 2. Now, since the same current I flows through both the resistances R1 and R2 connected in series, so by applying Ohm's law to both the resistances, we will get V1 is equal to I into R1 and V2 is equal to I into R2. This is third equation and this is fourth equation. Now we will put the values of V, V1 and V2 in the equation 1. Okay. Now by putting the values like this, we will get I into R is equal to I into R1 plus I into R2. Okay, now we'll write in a simple way. I into R is equal to, we'll take I as common and R1 plus R2. Now cancelling I from both the sides, we will get R is equal to R1 plus R2. So this R is known as resultant resistance or the combined resistance or the equivalent resistance. So if we connect these two resistances, then we will get this result. But if we connect more than two resistances, for example, say we are connecting 3 resistances, then R1 plus R2 plus R3 is equal to resultant resistance. Likewise, we can connect R4 and like this. So this is the resultant resistance. And this can be explained on the basis of the law of combination of resistances, which state that the combined resistance of any number of resistances connected in series is equal to the sum of the individual resistances. If the number of resistances R1, R2, R3 are connected in series, then their combined resistance R will be given by R1 plus R2 plus R3.